Hello and welcome to the Sustainable Materials Management Webinar Series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the Program Manager for the Recycling Market Center and will serve as your moderator today. Today's webinar topic is the upcycling end of life plastics. Our presenter today is Lauren Versagli, who I'll introduce in a moment. We're going to have a Q&A session at the end of the presentation, so if you have a question or comment, you can use the Q&A feature located on your control panel on your screen. Please note that an edited version of this webinar will be made available for viewing via YouTube links on both the National Recycling Coalition and PA Recycling Market Center websites. And also please note that the Pennsylvania Recycling Market Center, its affiliates and funders, and the National Recycling Coalition assume no liability resulting from the use of any information provided during this webinar. This webinar is only provided as an informational tool, and no discrimination is intended and no endorsement by these organizations is implied. And now I'd like to introduce our presenter. Lauren Versagli is responsible for corporate development at Plastic Energy with a focus on North America. She brings a strong background from the chemical industry and a track record of success in building teams and delivering collaborative solutions. Her core responsibilities include defining the company's strategy and developing partnerships across value chain that results in circular projects for plastic waste. Prior to joining Plastic Energy, Lauren worked at Hach as Global Business Unit Manager for more than 10 years at the Dow Chemical Company in the US and Europe. Her core responsibilities while working at Dow were in the water treatment business, where she held various roles from product engineering to technical service to sales and marketing. Later, she was responsible for regional business development and the company's 2025 sustainability goals in the Benelux. She received her MBA from IMD in Switzerland and her BS in mechanical engineering from Penn State in the United States. And so we're now going to turn it over to Lauren.
Thank you, Wayne. So good morning and good afternoon to everyone on the call. And thank you, Wayne, and also to the PA Recycling Market Center for giving me the opportunity to share with you a little bit about Plastic Energy. Here on our title slide, which you can see is actually one of our commercial plants that's located in Sevilla, Spain. And I'll talk more about that as we go throughout the presentation. I'm gonna jump right in and share with you the agenda, which we practiced would advance. There we go, and now it did. I'm just going to spend quickly one high-level slide on the background of the U.S. Plastic Waste Challenge. I had the opportunity to look at a lot of the attendees who were joining today and know that this is something that you're probably living and working with every day, so you're well briefed. And then just also talk a bit about advanced recycling and how that fits into the big picture and where we are as Plastic Energy in that. I'll go more specifically into Plastic Energy, who we are as a company, about our technology and feedstock, and then some of the exciting things that we've been able to accomplish in really generating proof points for the circular economy and what our future plans are. It sounds like there's going to be time for Q&A at the end, and if there's anything pressing, I think Wayne said that he can jump in the presentation to ask questions as well. So let's get started. What you have here is just some of the federal, state, and local policies. So obviously the idea, the challenge, the opportunity of plastic waste has, I think, really become in the forefront over the last several years. I first started working on this problem back in like 2015, 2016 with the hat of the petrochemical company. And so it's been really interesting to see it. You know, I first learned about it in Europe, and now I'm working back in the US. So it's interesting to see how it's developed and the different perspectives between the two continents. But I think in the US, some of the interesting things that you see is that the EPA had mentioned this year that it's going to set voluntary national recycling targets. And that's something that's going to be a first. There was a pretty strong legislation proposed to Congress in February this year about the Break Free from Plastic Pollution Act. So a lot of ways to reduce plastic production and also single-use plastics. More recently this summer, there was the Plastic Waste and Reduction and Recycling Act, which was about engaging federal support for improving the recycling infrastructure. And you have several states who have implemented and cities who have implemented single-use plastic bans and taxes. And then there's even been discussion about, on the recycling side, if we talk specifically about advanced recycling plants, how do we allow them and give them the opportunity to be regulated as manufacturing facilities instead of waste facilities? So all this to say, there's been more and more discussion and highlight and focus on what to do. I think some of that has also come, if you look on the right at the graph, when China implemented their national sword policy. So I know it's probably difficult to see, but I think the real point here is pointing out the disparity between what was exported for the first 6 months in 2017, represented by the black line, versus what was represented by the red line in 2018, so after the policy went into effect. And what you see is that there's many, many more plastics that are not being exported from the US, particularly the 3 through 7 bales. So we have more waste domestically to manage, and that's definitely affected how much is going to landfill, I think, and also even what's being collected in certain communities. So according to the EPA, we have about 35 million tons of plastics that are discarded. Around 14 million of that has to do with plastic waste packaging and containers. There's also a portion of that that's flexible packaging. Many people know that that's presented notorious challenges in the collection and sorting side. A lot of places it's really only accepted through store take-back programs. I know that there's a few examples where that's not the case in the US, but generally speaking, it's true. And it also provides challenges in recycling because it could be multi-material. And so overall, we get to the point where only 9% of plastics are being recycled. So, working on how do we improve that number. If we talk about where plastic energy and the technology that we have, which is considered advanced recycling, and particularly the core transformational step is pyrolysis. This image is adapted from the Ellen MacArthur Foundation. So the linear economy is you have virgin feedstock, you make the plastic, and then you have sort of these outlets, which could be incineration, landfill, some leakage, and of course, mechanical recycling. Much of what's mechanically recycled, of course, you have some losses and you have some cascaded recycling, which means it's going to reuse applications, but that are not back to its original high value applications, for example, in food grade packaging. So it could be park benches or bags or pipes. Definitely still useful, but doesn't completely close the loop. And so where Plastic Energy's technology sits is taking waste plastic all the way back to an oil so that it can be used as an alternative feedstock for the petrochemical industry. The one thing that we want to discuss and I think stress is that Plastic Energy and any advanced recycling technology should be a complement to the existing mechanical recycling infrastructure. So if we think about how things work today, you have the creation of plastic, it's used by the consumer, it goes to the mechanical recycling facilities. Some of it, as mentioned on the previous slide, can go back to the creation of plastic, and some of it is going here, most of it today is going this red route, so either leakage, landfill, or incineration. And what advanced recycling and where Plastic Energy fits in the picture is reject or residual from the MRFs, and it can also be from other, for example, other industries that have waste plastic, so like the automotive industry or maybe the glass industry and their recycling efforts, could come to what we call a TAC plant, be converted back into an oil, and then be sent back for the creation of plastics again. So it allows for further diversion from landfill and of course increase recycling rates. And it will also allow some of these brand owners who have signed on to the Ellen MacArthur New Plastics Economy to help meet some of their post-recycled content goals in their product packaging. I'll talk about this particularly in the end when I talk about the examples, but value chain collaboration has been, and I think will continue to be absolutely key to the success of advanced recycling. So with all the demand for PCR in plastic packaging, I think there's been a prediction that by 2025, I think between 5 and 7 million tons of PCR content would need to be available to meet them. I can imagine that that's already grown because more people have signed on since that number was calculated. And so the plastic waste would go to how the plastic would go through the value chain is that you'd have plastic waste, either from MRF residual or non-traditional sources. It would go to a feedstock provider, which could be like a secondary MRF or a plastics recovery facility or a pre-processing plant that would prepare it further to be appropriate feedstock for a TACOIL plant or an advanced recycling plant. And then it would be converted to oil, go to the petrochemical companies. Let me advance the slide to catch up. And then ultimately back to converters and brand owners so that they could incorporate the waste plastic into their products. And so then, of course, out to consumers and through this whole system, allowing recycling again and again through the advanced recycling model. Now I'm going to jump in and talk a little bit about plastic energy. So we are the only global company that has been successful and consistently produced enough chemical feedstock, meaning oil, that we are converting waste plastic back into food grade packaging today. The company is located in the UK. Our global headquarters are there. We have a team of about 50 people who sit in that office, a lot of engineers, admin. Our senior leadership team is there as well. We have a patented process that we call Thermal Anaerobic Conversion. So we call it TAC, hence we speak about a TAC plant when we talk about our production facilities, and also TACOIL when we talk about the product oil that comes from them, pyrolysis oil. We do own and operate 2 plants today. They're both in Spain. That's the result. Our founder and CEO is Spanish, and so when he first started the development of this technology and construction of plants, he did it in his home country. So Almeria was the first one that was started. It was started in 2015, so it's been operational for about 5 years, and Sevilla came online after that, so that's been operating about 3 years. I think this is really important and critical to where Plastic Energy stands today, because we've gained a lot of operational experience in running these plants and learning how to optimize the process and really continually run them with post-consumer waste plastic, and understanding, you know, how to make the process robust to handle the variation that comes with using not necessarily post-industrial or post-commercial waste, which tends to be more consistent in composition and cleaner. From a yield perspective, about 70% by volume of what goes in as waste plastic would come out as TACOIL. Again, that's the trade name for the pyrolysis oil. And we are selling the TACOIL today to major chemical and integrated energy companies. Initially, it was done for fuel blending and plastic production. And, but I think what I heard is that as of earlier this year, the output from our 2 plants is going all to plastics production. So really closing the loop and advancing the circular economy. At a high level, we just have on the right a picture of what the unit operations are within our plant. So we would feed end-of-life waste plastic through extruders to get some preheating into the reactor. In the reaction step, of course, is where you heat with lack of oxygen and get the conversion from waste plastic back to gases. You have tar and water as a byproduct there. Those gases pass through a contactor and then ultimately into a condensation or distillation unit. And then you have, in the final step, storage of the recycled oils. The way it works today is that the TACOIL from our plants are being trucked to the locations, the petrochemical locations where it's being converted back into plastic. So the process is robust. It's fairly uncomplicated. We run a semi-batch process. We don't use any catalyst today, so that's what we mean when we say there's no additional substances necessary. It's done at relatively mild temperatures and low pressure, especially compared to chemical processes. One very, I think, great thing that we've been able to do with our process is that there's some light non-condensable gas that comes from the reactor step, and we're able to use that in an integrated step as the heat source for the reactor, which means that step is energy neutral in the chemical process. The system is modular, so if we want to add volume, what we can do is add another module or train onto the system and then size up appropriately the back-end equipment. And I mentioned, I think on the slide before, that it is a patented process, and that is in the US and Europe. Again, just talking about what the product is, that's TACOIL, and it replaces fossil oil, traditional fossil oil in a steam cracker. And then there again, you have the conversion for product. On the feedstock side, just speaking high level specifications, we can take different grades of polyethylene, so linear low, low, HD, PE are all fine, polypropylene and polystyrene. And what causes problems in the process are PET, PVC, EPS, and some other category 7 plastics like ABS or PLA. We can take mixed and multi-layered plastics because they're mixed in with all the other things. So even if they're multi-layered, within limits, we've been able to process them and do process them through our plants. We can process rigids, films, and flexibles. In Europe, we actually process primarily film and flexible packaging, and we don't need to wash or separate these by polymer type. So we do basic mechanical recycling and sortation up front to get the feedstock specification that's required for a TAC plant. I think I mentioned also earlier that from a feedstock side, we are managing real end-of-life post-consumer plastics with their contaminants. We have a very good idea of how to control the feedstock to get the right output in the oil. And you see here that some of the contaminants in the TACOIL are monitored and important down to the levels of ppb. And a lot of that has to do with off-taker requirements for the steam cracker. And we know how to identify and tackle and work together with our off-takers to minimize those contaminants in our oil and or do some different things in our process to reduce them. We have a growing pipeline of projects. So the company, as I mentioned, is based in Europe. Well, it's in the UK, so I guess officially not part of the European Union anymore, but our first plants are in Spain. Those are the ones I've spoken about, Almeria and Sevilla. The environment, I think, within Europe is put more pressure on brand owners and the whole value chain to come to solutions. So you'll see that most of the projects in the pipeline that are announced are in Europe. So there's additional opportunity for us to develop a plant in Tenerife in the Gran Canary Islands. We're working in the UK. We're also working on a couple projects in France. One of the more public projects that we have is one in the Netherlands with Sabic. That was, I think, the first announcement we made. And we're also working with INEOS in Europe to see if we can develop another plant with them. So all of these are focused on plastics to plastics, so not going to plastics to fuel, and really closing the loop. And then as we move from Europe to Southeast Asia, we have a project that we're working on in Malaysia and also in Indonesia. And so now the task is how do we do some of this same work in the USA, and so leverage our learnings and success to get something on the ground here. Just to give you an idea of project structure, what it looks like for us. So the three big legs of the stool are a feedstock provider, ourselves as the advanced recycler, and also the petrochemical off-taker. So we tend to have long-term agreements on the feedstock side and on the off-take side as part of starting a project. The size of plant, the generation that we're working on and building today, the first one, for example, in the Netherlands, will be about 25,000 metric tons a year. So that's 75 metric tons of waste, plastic waste a day that's processed. That'll give about 21,000 cubic meters a year of TACOIL. Takes about 30 people to run that size plant, and just to give you an idea of footprint, it's about 7.5 acres. The last few slides are really focused on the examples that we have of closing the loop and doing plastics to plastics. So back in 2019, that was the first announcement done at Davos, where we worked with Renewi, who is a waste handler, and Sabic as a petrochemical company. And then you'll see some of the brands that have been since involved, Unilever's, Vivention's, Walkie Group, and Tupperware, where we took waste plastic that was converted in our Spanish facilities to TACOIL. The TACOIL was sent to Sabic's facility in the Netherlands. They converted it back into plastics, and then the brand owners used it again into food grade packaging. The product is certified and traceable through something called ISCC Plus. So that ISCC Plus looks at all the players in the value chain and verifies that the material is coming from waste plastic, and of course takes into account some process losses along the way. And the recycled content is attributed using what we call mass balance approach, which is something the industry in general is using so far with recycled content for plastic. It is an alternative naphtha-like feedstock, and it is a drop-in replacement for traditional fossil naphtha that comes from a fossil fuel, and again being made into food grade packaging. This picture here is from the K show, so it's almost about a year ago. This is images that we took from Sabic's stand, where you can see the Certified Circular Polymers. So this is packaging that they have on the market. It's Magnum ice cream containers and also Knorr soup containers in the European market that's being made with TACOIL from Plastics Energy's plant that's again converted by Sabic. So this was really exciting to see some of the first real proof points of closed loop circular economy. And then more recently over the summer, there's been a few more announcements. So we're working with Sealed Air to figure out how to collaborate with them on their plastic packaging, including R&D of eco-design and making their packaging also more recyclable for advanced recycling. There's been a value chain collaboration with Sealed Air, Sabic, and the UK has a supermarket, Tesco, with Bradbury cheese, where the cheese packaging is also being made with PCR material. And then Berry also announced with Mondelez through their relationship with Sabic that their packaging for Philadelphia cream cheese will also have post-consumer recycled content. So again, really exciting to see real life examples that we interact with where you can see plastic waste being used again in food grade applications. The future plans for Plastic Energy looking forward, we'd like to build 10 to 20 plants over the next 5 years. Again, promoting plastics to plastics where we can. Perhaps there may be some cases where we do need plastics to fuel options, but doing that across 3 to 4 continents. So what we're doing in Europe, Asia, hopefully expanding operations to the US. We absolutely want to continue advocacy for advanced recycling globally and just show that it is one of the tools to help tackle the plastic waste challenge, and then continue to work with the value chain all along to bring these further examples to the market for plastic reuse. I think the next slide here is a video that I'm going to attempt to play. Hopefully it comes through. Yes.
Let's develop technologies to improve the quality of living. Plastics have enabled us to reach space, to improve agricultural production, and enable food and water to be distributed in a hygienic way. They also revolutionized healthcare and helped to save lives every day. However, our lifestyle also generates serious problems due to the ways in which we use plastics. Life cycle of less than 12 minutes. The plastics that we use and throw away every day are rarely recycled and end up piling up in landfills, our oceans, and rivers forever. It's estimated that our oceans hold in excess of 150 million tons of plastic, and that almost 70% of the seafood we consume is traces of microplastics. If we continue in this direction, by 2050, there will be more plastic than fish in the sea, and the situation on land will further worsen. How can we manage this plastic which threatens our planet's existence?
Plastic Energy has been working to find a solution over the last 10 years, and today we have news to share.
Thanks to a unique process, we've been able to recycle the plastics no one wants, which cannot be mechanically recycled to obtain TACOIL. It's an oil which can be used to produce new plastics or alternative transport fuel with carbon footprint. This technology reduces fossil fuel consumption used to create virgin plastic. This is not science fiction, it's not a project or a dream. It's a reality which is already up and running 24/7, 365 days a year at our plants in Almería and Seville in Spain. It allows people to continue enjoying the advantages of plastic, minimizing its detrimental effect on the environment. This is a new hope for plastic recycling, which we would like to bring to the entire world. A process which has made us world leaders in the circular economy of mechanically recycled plastic.
It's a great time and hope that this mechanism there must be more solutions that many societies will help us with this suffering situation.
It's a new technology which is making a big change. A change which on a daily basis inspires and motivates our London, Almería, Seville, which will enable us to jointly make a difference in a world where using plastic will no longer be a threat. Technology which will help us look after our cherished planet. Plastic energy, technology to recycle our future.
Okay, great. Let me go back to the presentation here. Yeah, so that brings me to the end of what, oh, hold on, let me pause that and come back here. There we go. Brings me to the end of what I wanted to share with you guys today. And I guess, Wayne, I'll turn it back over to you so that you can handle and address the Q&A section. And thank you again.
Thank you, Lauren. So we're going to do some Q&A now. So if you have any questions for Lauren, please use the Q&A feature on your control panel. First of all, maybe Lauren, if you want to put up that YouTube link, the audio is kind of choppy, so in case
Oh, sure. Yeah.
Do their own YouTube view on that.
I'll take a note and send that. Absolutely. Thank you for letting me know.
Okay, great. So I think this first question was already addressed. You covered the efficiency of the pyrolysis. It was about 70%. And the question was, can any type of plastic be used? And you actually listed the no-no resins. And I was just curious to the questions. Some of the questions here are, why can't those particular resins be used in your process, particularly PET, PVC, EPS, and the category 7?
Yeah, so they introduce contaminants either into our process or into the final product TACOIL that don't meet the specifications for our off-takers in the petrochemical industry for their steam cracker. So for a naphtha-like alternative.
Okay. What's the unit you call the contactor? What is that unit in your process?
That is a unit operation that helps us get some of the physical properties that we want in our final TACOIL.
Okay. And this is a chemical engineer question, I can tell. What is the polymer to polymer yield? I see 70% liquid yield, maybe 70% as naphtha cut, and 30% as ethylene yield in the steam cracker. That would make 15% yield PE to PE. Is that correct?
Okay, let me think about the question. So polymer to polymer, yes. So we would get roughly 70% by volume from waste plastic to TACOIL. And then when that goes to a cracker, there is, every cracker has specifics based on its process, but there are some generally published, like, let's call them product slates from steam cracking. And off the top of my head, I think for ethylene, it's roughly 30 to 35%. And then you have propylene, aromatics, et cetera through it. So yes, if you're doing it from that standpoint, I think that's true.
Okay. Again, on the problematic resins, this question says, it was indicated that PET is a problematic input, yet PET packaging is illustrated as an output of TACOIL. What's the issue with PET processing through this process? I think you addressed that.
Could you repeat the question? Sorry, I couldn't hear it fully, Wayne.
Yeah, it was indicated that PET is problematic, but in the packaging slides, it's illustrated as an output for TACOIL processing. PET packaging is an output of TACOIL.
So PET introduces some of the contaminants that would end up in the TACOIL that can't be processed, or that the petrochemical companies want to limit in their specifications for an alternative naphtha. I think some of those specifically could be chlorides, chlorines, things like that. I don't remember the specific slide that's being referenced about it being an output. I'd have to go back to the presentation and listen, or look, sorry.
Maybe we can do that at the end if we have time.
Yeah.
There's questions, are you considering Africa as a possible location? And then there was one question on, can this technology be used on islands where there's smaller generation of plastics, tonnage-wise?
So my responsibility is specifically looking after North America, so I'm not involved in any discussion around what's happening in Africa. I think some of the team that's in Europe are looking at other geographies in the world, so I don't know the specifics for that and exactly where we're at with looking at Africa. It can be used, I mean, one of the examples I showed was that we're looking at building a plant in the Canary Islands, so it could be used for certain islands, but there is also a balance of economies of scale. So I think it too small would not be economical, although technically possible.
Another naphtha question. Is there a maximum mixing ratio of naphtha to TACOIL in the downstream cracker?
It depends on the petrochemical company, so that's not something that I have visibility into.
Okay. I don't know if you can answer this question as far as your, the emissions of the plant. Is it a very, I don't want to say dirty, but the pollution output, is that an issue with this technology?
I do not have all the details on the plant emissions off the top of my head. If there's specific ones, I mean, I can probably follow up directly by email. I mean, we do operate the 2 plants that we have in Spain, of course, completely in line with national and European regulations for emissions and any type of discharge.
What do you do with the residue from the process? Is that like a NASH or a char?
Yeah, so the char can be sold into other industries to be used as a caloric heat source, or it could also be landfilled. And the water that comes from the process is treated and discharged. Everything has to be done in accordance with local regulation and discharge limits. So that would look different, depending on where the plants are.
How far from construction is in your U.S. presence?
So from the time we would sign a memorandum of understanding to work with a group of people, it takes about 3 years. So it's at least 3 years away for a commission in the USA.
Okay. This one attendees saw the video on the technology using an auger screw system. Is that correct?
The plastic are fed through, the waste plastic is fed initially to the reactor through an extruder system. I'm not sure if that's what they're referencing.
Is there a limit on how many times a plastic can go through this process? So
because the end product is oil and it's recreated again into new plastic, and our TACOIL is then introduced to the cracker, no, it should be able to continue to go through the process.
Are there any other byproducts other than the char you mentioned, and how are they handled?
So we have char, water, the non-condensable gas, which I mentioned, which is used as an integrated heat source, and the product.
I missed one earlier on. Is there any, have you done any testing, like a leach testing on the plastics using your material, particularly food grade? Are there any issues with that?
Yeah, so the plastic can't be considered food grade unless it's gone through, I guess, the certifications that it's required. Because what we produce is oil and it goes entirely back through the petrochemical process. So through the cracker, the polymerization and conversion steps, I believe it's the same as it would be with using all virgin material.
Okay. Would TACOIL be able to be used in a CNG cracker plant?
I don't know the answer to that question.
Okay. If a city was interested in starting the conversion for bringing this process to the state and our country, what would your advice be? I.e., what general partners would be required, initial startup costs, land use, etc. It's a tough question.
Could you repeat the beginning of it?
If the city was interested in starting the conversion for bringing this process into this state in our country, what would your advice be? I guess how would you?
You should reach out to me,
Right.
and we can have the conversation offline. I mean, I think the one, just to answer at a high level, I think the big thing is, and I mentioned it on the project slide, is making sure that we have so long-term feedstock supply, long-term offtake supply. Those tend to be kind of, like I mentioned, the legs of the stool to get things going. And of course, we're working with partners on both sides of that. But always happy for interest and inquiries, so please feel free to contact.
And I'm not sure this is worded correctly, but I'm gonna try and do this. How is the policy approach towards oil, due to the facts that in some places oil is seen as a fossil fuel? Here in California, the Public Resources Code considers pyrolysis as a transformation rather than recycling, and they put it in the same category as incineration.
Yes, that's exactly correct. We've come across that and had some discussions in California about that specific point. So I guess it's something that we're aware of, and in certain states, the technology as it stands today would not be considered recycling. But I think that there is some opportunity to reevaluate that. I know some of those have just been based on historical information. I think with advanced recycling technologies, things have changed a bit, and it's worth taking a second look at. But absolutely correct point, and acknowledged that it's true and something to work on.
Can you share any cost per ton figures on your cost to process 1 ton of plastic into the chemical stock?
So I'm not going to share anything specific. What I can tell you today is that it does cost more than the market price of naphtha because the technology is being developed, but we have, of course, a pipeline of generations that are absolutely addressing that fact and looking to bring it more in line and on parity for cost.
Would co-extruded PE films with nylon also be a problematic material?
Difficult question to answer because it depends. So nylon is not something that we want in our process, but I think probably today it is being processed in small quantities because it could just be accidentally in the stream, but it's so small that when it's mixed with the entire waste stream, it's not presenting an issue, but I don't know the exact percentage at which it would become problematic.
Okay, I'm not sure if you can answer this one. What is next in terms of pyrolysis or other chemical recycling technologies? Are there currently research projects ongoing at Plastics Energy?
Of course. So we're always looking on how to become more efficient, improve the technology, continue to reduce contaminants in the final product. So yes, there's definitely research and work looking ahead to next generations. I think that's generally true of the industry because the technology is, although pyrolysis is older, advanced recycling is fairly new as an industry. So yes.
Okay. So I think we got to the questions pretty quickly here. Thank you for those questions. Some were pretty challenging. So we're gonna wrap it up here. Again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. If you also would like a copy of the slide deck, we can provide that if you just email us. And so thanks again for joining us. We hope you'll join us for next month's webinar. And please visit the NRC and RMC websites for schedule updates. And thank you again, Lauren, for a great presentation.
Yeah, thank you for having me.
Okay.
Thanks for listening in.
Yep. Okay, have a great day, everybody.